Hello, everyone. I welcome you all to lesson number two on SharePoint, and this is gonna be on SharePoint architecture, right? So let me put down the topic. Today I'm going to use the whiteboard because we need to learn about SharePoint architecture, okay? And yes, this is lesson number two. Pardon my handwriting. I have a very bad handwriting. And first of all, I would like to apologize that it's been quite some time. I was not able to put the second video or the other videos. The reason was since it's a COVID time, even I was being impacted because of illness, fever, and all of that stuff. So I apologize for that. But nevertheless, learning should not be stopped, right, in any of the circumstances. So let's have our second video today. So we are going to talk about SharePoint architecture. Now, when we say we are we wanted to talk about architecture, what exactly comes into your mind when we say architecture? Definitely we talk about servers, right? Now, spelling mistake. Yeah, I'll just write it down again. So we are talking about servers, right? Now, what all type of servers are we talking about? What all servers are being used when we have to design a SharePoint architecture? So, firstly, people who are aware of little bit of background on how servers used to work, right, or how we define our servers. So, there is something known as tier, um, you know, tier layouts. So we have a tier one, tier two, tier three. So these are our server layouts. How exactly we say that, okay, our infrastructure or our architecture is a tier one architecture, tier two architecture, tier three architecture. What exactly does it mean? We are going to talk about this as well. Okay. What servers are required? What type of servers are required in SharePoint architecture is the second thing we are going to talk about. And the third thing is how exactly we define a server, how we say that, okay, these many servers would be required. Okay, so that is something again we are going to talk now. And also we are going to extend this video a little bit more on understanding how we decode a SharePoint site, okay, and in terms of URL, how exactly a URL designing happens. All right, so let's talk about first of all, the tiers which we say. Okay, tier one means only one server, a standalone server. Tier two means two servers where we can define different set of roles of the server, and we're going to discuss about the roles. And tier three means three servers, or even it can be more servers, but the three, the count of three is the type of role, what a server is playing a role. Similarly, role, role, okay, they all are role based. So one single server or two servers, what role are they going to play? Okay, now in SharePoint there are majoritively three server roles, majoritively. Okay, now if we talk about in today's scenario how 2019 server SharePoint 2019 works, they we have multiple type of servers and roles which we can define, but majoritively we have three set of servers. Number one number one is our database. Okay, here we generally use SQL. Number two is application server. All right, and the third one is our web front end. Okay, now I am going to nomenclate this as DB. nomenclating app server as app for now. Okay, and web front end as WFE. Okay, please remember these three nomenclations for my description when I'm going to design the server, how exactly things used to work. And also I'm going to use their names like DB server or app server or WFE. Okay, so these three are something which you just keep in mind. These three are our roles. So when we say we have to use one server, so that means one role being defined on that server, or rather, I would say one server serving all roles. Okay, so tier one server is a standalone server, like I stated. So that standalone server means that it is going to host SQL, it is going to host application server, it is also going to host web front end. And we are going to talk about what exactly they mean altogether. Okay, two servers again. In two servers, we can say that okay, one server can be a database server, and the second server can serve as app server or web front end. Or we can say that one server can be a database server and application server. Then we have a dedicated web front end. Or we can say database server and web front end are at the same one server, and application server is on the other end. Okay, so the third server is like that. Correct. So the roles are again defined. And on a similar context, if we say this, how three server works. Again, three roles, one server for DB, one server for app, one server for web front end. Now, what if I need more servers for DB? So I can say that three servers or three-tier server is something like wherein I have two servers of SQL, one server which is serving app and web WFE, both. All right. Now, this is not gonna be tier three, I mean, which means that only three servers are required. I can say that I am adding, let's say, five database servers, three web front ends, and one application server. This is also a tier three server. Now the question may arise, okay, I'm saying that, okay, one, two, and three is the count of roles I'm defining, but wherein I'm asking for three roles, or so many number of servers. Again, I'm counting on the, server base. So that's not the point. The point is, as I stated, it's on the role base. So what is the role over here? So the role is DB, web front end, and app. These are the three roles, and the number of servers can be any, right? Which is why the number over here, the number would not count, but the roles will count. So we have three roles, one, two, and three. That's why it will, this server, which is, or this infrastructure, which have total of nine servers, is going to be counted as a tier three server only. Fair enough. So this gives us a structurization when we say that, okay, our infrastructure is a tier one structure, tier two structure, or tier three. Again, in tier two also we can have, let's say, two DB servers. Uh, we say this, we have two database servers and two application servers plus web front end, right? So again, though they count as four servers, but since we are defining the roles on two set of servers only, or rather we can say two roles are being defined in such kind of an architecture, then yes, it is a tier two. Got that point? Great. Now let's move ahead. The next thing which we are going to talk on server is, so this defines our servers. Now let's talk about the type of servers. Okay. Now what we have is the first categorization of server, that is our database server. So you might be aware that SharePoint uses SQL as its database. So that is for sure. We are talking about a SQL server. Now, this SQL server can be of any version depending on the version compatibility of the version of SharePoint you are going to install. And along with that, the concerns. Now, if in case I talk about standalone, right? I may use a data center version of SQL. I can use an enterprise version, right? I can use even the native client which gets installed. So what happens is when I am creating a standalone environment, when I start installing SharePoint, we do have an option whether you wanted to create a standalone machine or a farm. So a farm is nothing but it comprises of multiple servers, whether we talk about a tier 2 or a tier 3. Okay. So if I'm creating a farm, obviously I must have a SQL server available to me, which means a server which contains or which have a SQL installed on it. Okay. Otherwise, if I talk about a standalone machine over there, the system itself configures the very basic or native, version of SQL on the machine itself. And over there, it creates its own application and a web front end also. So basically, the SQL server will be our database server, and that's majoritively the statement, right? We all know what a SQL is. If in case you do not know about SQL, you can look for more videos to learn what exactly SQL do. But in a general term, it's a database. It's a place where we put our entries. We create tables. We have the inputs. We take we run the queries to fetch the information. So that's our database. Then we have our application server. Now, application server have multiple roles. Okay, what exactly does it mean? Since it is named as application server, so you can understand there are multiple applications which we run. Okay, previously in the old versions of SharePoint, we only have one application server which serves all type of services or all type of applications altogether. Now what applications am I talking about? And we are going to discuss it in the later videos when we go in depth of SharePoint. So applications can be, if I talk about some Excel services, some search services, some user profile services, right? Metadata services. There are many services which are available, or many applications which are available which we can create, all right? And that is being served by an application server, all right? So now in today's world, I can have a dedicated machine for all of these applications, or even I can have a one machine for all of these apps. So for an example, like I stated, user profile service, search, metadata, right? Or office applications, office applications. Now, either I can have these multiple machines or I can just have everything in one, right? And furthermore. So that is my application server, right? Now let's talk about web front end. Now, what does this name gives you, or makes a picture in your mind? It is web front end. So that means it's the front end machine for the web. So any request which you send on the server will be first of all catered by web front end. This is our guard of everything. You can say that, okay? Or whatever you wanted to say. This is our first machine which is going to take the request from the internet. All right. Okay, just give me one quick minute over here. Okay, sorry about that. So I believe that clarifies what is a web front end. Okay, now let's move ahead. What I'm going to do now next is let's talk about the URL. How exactly a URL is decoded. Now, this is very much important to understand how a URL is decoded. Only then you would be able to understand the functionality of all of these servers. Okay, so let's first of all talk about how exactly a URL is decoded. So let's take an example. Okay, the example is, and the very famous example is, we have a URL of google.com. Okay, how are you going to identify this when we say that, okay, let's say I'm from Google. Okay, I have designed this architecture wherein there is a database, there is a application server, there is a web front end. Now, how am I going to tell, or how am I going to cater the request when a URL is browsed? Okay, so the decoding of the URL happens from right to left. I repeat, the URL's decoding takes place from right to left. How exactly it happens is, okay, I mean, I am not sure if anybody is aware of this kind of a terminology, whether it is, kind of a myth for you, or somebody makes you learn about this or no. I take something as an example. I say that, okay, what happens is when we have a URL, there is a hidden dot at the end of every URL from a decoding perspective. Now, what exactly this dot is? This dot actually defines how your internet browser is going to crawl the information, or give you the information. So in the network world, I say this, that this dot is sitting at the very of everything top of everything. Okay, when a URL is decoded, okay, it sees that, okay, this is about this dot, and obviously there is nothing else apart from it. Then the first thing which comes to the scanning is .com. Okay, now what exactly this .com is? There are zones, okay, which this dot is linked with. There is a private zone and there is a public zone. This private zone contains these kind of, you know, entities like dot .mil for military, dot maybe there would be something known as dot .nasa, right? There would be something known as mm, uh, priv. I'm just taking an example, okay? So they are the domains, or they are not the domains, but rather, um, what do we call it? Let me just, so like, yeah, we can say this. These are kind of some domain name kind of things. We can say this. I mean, it's I'm just forgetting the name. This is how we used to have a domain name, abc.com, or I define them as zones. Okay, these are the zones where exactly we used to define our domains. In public, what is our most common one is the .com, which is for commercial. Then from .org, organizational, right? um, what else related to maybe some kind of, we have .inc, incorporate, um, for we have like .co, .in, right? But how exactly .co, .in comes into picture? It's not like this. uh, you know it is being defined as .in, and within .in we have .co, .in, .org. Again, I mean, they are being defined with respect to in, right? This is IN is for India. Similarly, we have for Australia, for US, and there can be many more, right? That's how a public, domain naming convention, or extension is being defined in the in the public zone. In the private, they are some, you know named, or domains which, or this domain names like .mil, right? Restricted zone, right? Restricted zones which are not available to common public. They are being browsed on a very secured network, obviously. and then the domain is being defined, and accordingly they would have their own separate dedicated network on which the requests would fall. So now we know that okay, this is .com. Now what happens is when the browser is going to crawl this URL, index this URL, or to search this URL, not the indexing, I'm sorry, when it is going to crawl and search this URL, how exactly it would work? So first of all, it will look for a dot, yes. It will go and check which zone it is going to be defined for. So it's like .com. So definitely it is a public zone named domain. Then comes the in the public zone, there will be many IS, ISV providers, right? We do have a network hub center, then we have ISV providers, right? Obviously, on that, there would be some kind of IP which would be defined. So there is something known as private IP and public IP. I believe you guys would be aware of what is private IP and public IP. If not, please do provide your comments on the video if you do not know about it, and I'm going to take another session. I'll just create a short video for you guys to give you a description what exactly is the difference between a private IP and a public IP. All right. So this kind of information, it will say that okay, on some public IP, there is a domain named being declared as google.com. Okay. So what happens in GoDaddy, for an example, we take the domain providers. We do have a domain providers. Over there, we register our domain, or we take the domain name from their servers. And what they do is we define an IP and they publish our domain to the cloud, or we can say to the world. Now, accordingly, in that domain provider, we are defining a name that this is my domain name. Okay. Now, since when we see this, if you might have seen, what we say is okay, google.com is a domain, and that's it, we need to hit, right? There is nothing else after before Google which is mentioned, right? So I need to hit the server which is going to give me the result from google.com, right? So what it's going to do is, as it crawls, as it looks for the information, it comes to the public zone, it comes then to the ISV, and it finds out that okay, there is a google.com being registered. Now, what is the function of that ISP provider and the domain provider is where the place where this particular domain is registered, there will be some IPs which will be defined for the network where this request should land. So there can be some IPs like 192.168.0.1 to 0.0.10. 192.168. Okay, so that means I do have 10 IPs, 1 to 10 IPs, on which this particular request of google.com can go, right? So what these IPs will be, these IPs are defined or assigned or aligned, whatever terminology you wanted to say, to one server each. One machine, and one server is nothing but a machine, right? And which means that every machine would have its IP address being defined like this, 192.168.0.1. And what are these servers then? These servers are nothing but our web front end. So if you see the complete flow, how exactly it works, when you're browsing from google.com, or where you're browsing to google.com, which is the website. I'm not saying we are talking about the search engine. We go to google.com and we start typing the search engine and whatever. That's the internal part. But first of all, think of how you are browsing the site. So as soon as you browse to any URL, it is being defined that okay, it is a public domain, categorized with a public domain. Then okay, here we have, it's I'll just use a different pen so that you know So yes, we are using the google.com. .com is a public one. Public one, then public one will say that okay, it is .com. The .com is linked to this ISV providers. Okay, it cannot be only one, right? ISV providers. With the ISP providers, it is going to tell you that, okay, yes, it is registered to me. There are these IPs on which this domain is registered to. You must forward this request to any of these servers. Now, how exactly when I said it is going to be sent to any of these servers, if you are aware of, there is something known as network load balancer. Okay, there is a network load balancer. So generally what happens is there is one IP being defined for network load balancer, which is linked to this domain. Within network load balancer, you have multiple IPs being defined for all of the servers, which are your web front ends. And accordingly, with the algorithm which you run in the network load balancer, the request goes to, let's say, this server, and this server is going to give you the request. Now, let's take an example over here. And again, this is a very good, thing to understand. Sometimes what happens is, let's say you are sitting in a cyber cafe. Okay. Now, let's say I am browsing to google.com. Okay. And when I try to browse to google.com, I am getting a response. Whereas my colleague who's sitting besides me, he also types google.com, and when he tries to hit the browser, it does not happen. I mean, my colleague is not able to see google.com as a site. It gives him some kind of error, 503, let's say for an example, or maybe some other type of error. I'm able to browse it, but he's not able to browse it. So how exactly that happens? And again, you can correlate this to your organization. How exactly this happens? If in case you are browsing to one of the sites and that is hosted by your organization, you say that some users are able to view the website, some users are not. How exactly that happens? The methodology is when the request comes to your servers, to your network load balancer, okay, it routes as per its algorithm, it routes the request to the next available server or next available, I won't say available, but rather next aligned server, number of servers. So let's say maybe the algorithm says 10 requests should be sent to server 1. So it will send the request to number 1. The 11th to 20th, it will send to number 2, then so on and so forth, right? So let's say maybe your request, like my request was the 10th request, so it's sent to number 1 server, whereas my colleague's request was the 11th number, so it was being sent to second server. So first server was working fine, but the second server was not working fine, because of which my colleague received an error. So that's a way of troubleshooting as well. All right, so that's how we, you know define how a URL can be browsed. Now let's take another example. Okay. Now this is gonna be a weird one, a little bit weird one. And let me tell you this, there might be a question, why do we write HTTPS? Why do we write www.google.com? Why only HTTPS without www? I can still search google.com. And that's a question for you guys now. Let's not talk about HTTPS. I'll give you the answers. But can any one of you give me the answers in the comments? Why do we use www? Or why we do not use www now anymore? So that's a question for you guys, so that others who are watching this video or wanted to learn about this can get the answers. And let's make it an interactive one. Let's not be a little bit of boring one that okay, we are going to limit it. Fair enough. So like, and this is the question for you guys. Now I was talking about another example, how exactly we can decode to understand the request. So HTTPS, let's say abc hyphen um, xyz dot sumit.com, right? If in case we talk about this thing, how the things are going to be crawled, or how it would be decoded from right to left. So first of all, it is going to check .com, then it will check a domain sumit.com. Now, if in case sumit.com is not found, it will see that whether abc.xyz, abc-xyz.sumit.com is a domain which has been registered or no, or is it a subdomain, or what exactly it is. But if it founds something at sumit.com, the request goes to a server. On the server, it will see what exactly is abc-xyz, which it wants to be populated on the browser, right? So the decoding happens accordingly. I just moved one step ahead to tell you what exactly abc.xyz can be, right? So we are going to talk about this in next session. I rest my today's session right over here with a question which I asked you on www. Please do give me the answers. Do let me know if you like the pace of this particular session and the way I'm moving ahead on, providing your comments. Please do forward this video to your colleagues to subscribe and hit the bell icon to get more videos on it. And definitely, I'm going to be more prompt in sharing more videos. I hope you liked today's session, and I wish you all to please be safe, stay strong in this kind of a situation. And thank you for attending this video. Take care, guys. Bye.